You know that feeling, right? If you're an engineer, you definitely do. All your dashboards are a beautiful sea of green. Everything's running just fine. And then the texts start rolling in from friends, from colleagues, all saying the same thing. Huge services are just down. It's like the internet decided to pack up and go home for the day. The weird part is, the fire isn't in your house. Your systems, they're totally fine. Your servers are humming along. No alarms are blaring. But yeah, you look out that digital window, and it really does feel like the whole world is on fire. It's this strange phantom pain that raises a really scary question. I mean, seriously, if your code is perfect and your uptime is solid, but nothing out there actually works, what on earth just broke? Well, the culprit is almost always something we rely on every single second, but hardly ever think about. So our prime suspect in these huge, mysterious outages is usually a core piece of the internet's whole architecture. It's something that acts like its central nervous system. I'm talking about the domain name system, or DNS. You know, the easiest way to think about DNS is just like the internet's phone book. We remember names, right? But computers, they speak in numbers, these things called IP addresses. DNS is the magic in the middle that looks up a name you type and gives your browser the right number to dial. Without it, the internet is like a city with no street signs. You'd be totally lost. And when this invisible, super fast system fails, well, the consequences are anything but small. But here's the thing. Foundational systems like DNS are just one piece of this puzzle. The entire digital world is built on layers upon layers of code. And what's truly wild is how often the real culprit behind a global meltdown is just a shockingly tiny piece of that whole structure. And this classic XKCD comic just illustrates the problem perfectly. It shows our entire digital world as this massive, complicated Jenga tower. But the one piece we're about to focus on, the one that can make the whole thing just tumble down, is this tiny, forgotten block that some person has been thanklessly maintaining for years. And back in 2016, this exact thing happened. It took just 11 lines of code, a simple little package called leftpad being pulled from a public registry to break thousands of major web applications. I'm talking huge projects from Facebook and other giants just stopped working. And you think 11 is small? It gets even smaller. A massive Google Cloud outage in 2021 that took down Spotify, Discord, and tons of other sites was triggered by just a single line of code. One. Now, what's really interesting here is the contrast between these two stories. On one hand, the leftpad incident was, you could say, a social failure. A developer felt like he was wronged, and in protest, he just took his code and went home. The Google outage, on the other hand, was a process failure. A single line of code was missing a really basic safety check, and it was deployed without an off switch, what we call a feature flag, which made a crash pretty much inevitable. So two totally different reasons, but one identical, catastrophic result. So, the crucial takeaway here is that these aren't just isolated freak accidents. They actually reveal something fundamental and, frankly, a little terrifying about modern software. Everything depends on everything else. Let's just trace this out for a second. Let's say you're building an app. You use a popular tool like Facebook's React to save a bunch of time. Okay, but React itself depends on hundreds of other smaller pieces of code, and those packages depend on even more packages. You follow that chain all the way down to the bottom, and you eventually find yourself depending on that tiny 11-line leftpad function written by some developer you've never even heard of. So when that one little block gets pulled, the entire tower starts to shake. And look, this is a feeling shared by a lot of people in the industry. After that leftpad thing happened, it became painfully obvious that what we've built is incredibly powerful, but also incredibly fragile. It really is, in a lot of ways, a glorious house of cards. So when you put these incidents side by side like this, a really clear pattern starts to show up. Whether it's relying too much on tiny little packages, or not having basic defensive coding, or centralizing critical services like DNS, the theme is always the same. Hidden, single points of failure that can cause these massive, cascading collapses across the entire system. All right, so how do we fix this, right? How do we build a digital world that's a little more resilient? Well, the solutions really start with the hard-earned lessons from folks on the front lines. These are kind of the first lines of defense. Using feature flags, which are basically just on-off switches for new code, gives you an escape hatch if things go wrong. Validating inputs with something as simple as a null check can stop one single bad piece of data from crashing everything. And using more than one DNS provider, well, that's just not putting all your eggs in one basket.
These are the practical, real-world steps that prevent the last crisis from becoming the next one.
But what if we could go beyond just fixing our mistakes? What if we could actually mathematically prove that certain kinds of bugs can't even exist in the first place? Well, that's the whole idea behind something called formal verification. The best analogy is this. It's like checking a skyscraper's blueprints to prove its sound instead of just building it and then stress testing it to see if it falls over. And this diagram here shows you what that actually looks like. It's from a project that formally verified a next-gen internet router. So instead of that tangled web we saw before, you get a system where every single layer is proven to work correctly with all the others. It's really the difference between a house of cards and a carefully engineered bridge.
Now, building these super robust systems is absolutely the future, but it doesn't change a fundamental reality for every single service online today. There's one component you just can't afford to ignore. Think about it for a second. Before your amazing, formally verified, super resilient application can do anything at all, a user has to be able to find it. And that very first step, every single time, is a DNS lookup. It is the absolute beginning of every single interaction. And this quote just says it all, doesn't it? For anyone who builds or runs anything online, I don't care if it's a personal blog or a giant global company, DNS is not just some technical detail. It is the front door. And if that door is locked or if nobody can even find your address, it doesn't matter how incredible everything is on the inside. So that leaves us with one final thought to chew on. We've seen how a few lines of code or a single little configuration can either support or completely shatter our digital world. The left pad package, that missing null check, the DNS entry. It really makes you wonder, what's the tiny, forgotten, invisible block that your world is built on?